Okay, let's talk about colonizing Venus. Seriously, it might just be the most elegant, the most brilliant off-world idea anyone has ever come up with. Imagine this, a floating city high up in the clouds, a real sister planet to Earth. I mean, on paper, it looks absolutely perfect. But, and there's always a but, isn't there? Hiding right there in plain sight is this one single devastating flaw. A flaw so big, it makes the whole beautiful idea just fall apart. So what is it? What's the fatal catch? And this right here is the central conflict, the whole story in a nutshell. You've got this dream of a paradise at a very specific altitude. But just a little ways below that, you have the reality. A hellscape so hot it can melt lead under pressure that would crush a submarine. The dream and the brutal reality are separated by just a few dozen kilometers of air. So let's start with the dream. Let's really dig into why this idea has captivated scientists and engineers for more than 60 years. Because, at this one special altitude, Venus isn't just survivable, it's almost comfortable. First up, the temperature. Forget about the insane heating and cooling systems you'd need on Mars or the Moon. 50 kilometers up in the Venusian sky, you're looking at a balmy, consistent 75 degrees Fahrenheit. You wouldn't even need a fancy thermal suit. Maybe just a light jacket. It's incredible. Then you have the pressure, 1 bar. Now that's exactly the same as sea level right here on Earth. Think about what that means. You wouldn't need a bulky life or death pressure suit. Just a simple oxygen mask would do the trick. A hull breach wouldn't be some explosive decompression event. It would just be a manageable leak. That's a huge game changer. And then there's the gravity. You see, a mission to Mars means you spend months in 0G, and then you have to live in just 38% of Earth's gravity. That stuff leads to serious bone and muscle loss. But Venus? It offers 90% of Earth's gravity. That is so close that our bodies might not even notice the difference. It's a massive health benefit. And really, when you put it all together, side by side, the difference is just stark. Venus's super thick atmosphere gives you this amazing radiation shield, something Mars barely has and the Moon has 0 of. On every single major metric for keeping humans healthy long-term, pressure, gravity, and radiation, Venus at 50 kilometers wins, and it's not even a close race. And here is the most beautiful, most elegant piece of physics in this entire planet. On Venus, the very air we breathe, a simple mix of oxygen and nitrogen, is actually lighter than the carbon dioxide atmosphere all around it. So what does that mean? It means a habitat filled with our own air would just float effortlessly, like a balloon. You wouldn't need any power just to stay aloft. It's almost too perfect. But this is where that beautiful dream starts to crack, because that gorgeous golden cloud layer that makes everything else possible, it also hides a planet-wide assassin, one that makes everything impossible. Yeah, there is absolutely a catch. And it's not some small little engineering problem we can figure out. No, it's a fundamental environment-defining flaw that completely negates every single advantage we just talked about. You see, the clouds, they aren't made of water vapor like on Earth. They are made of concentrated sulfuric acid. And we're not just talking about a little bit of acid rain here and there. The entire habitable zone is saturated with a fine mist of this stuff, an aerosol that you cannot avoid, you cannot shelter from. It is literally everywhere. And just look at the concentration here. This is, wow. We're not talking about some weak diluted acid, no way. The stuff in Venus's clouds is as strong, sometimes even stronger, than the pure industrial-grade acid you'd find in a chemical factory right here on Earth. Think about that. It's an environment that is actively, aggressively trying to dissolve anything and everything that enters it. So, okay, engineers are clever people, right? Of course they've proposed solutions. But what they've found is that for every ingenious fix to this acid problem, they just uncovered a deeper, more fundamental issue. It's like a chain reaction of failure. Let's see how it starts. The first idea was pretty brilliant. If staying still means you get dissolved, then just don't stay still. Keep moving. But wait, to move you need engines, right? And propellers and power systems. And guess what? All of those systems corrode too. The very act of trying to escape the corrosion just subjects your escape vehicle to the exact same corrosion, plus all the mechanical stress of running 24/7. Okay, you might be thinking, let's just send robots first. It's a good thought, but the problem is the communication lag. Light takes time to travel. With a round-trip delay that can be up to 28 minutes, a human on Earth literally can't fix an unexpected problem in time. By the time mission control even sees something's wrong, the robot could already be gone, dissolved by the corrosive environment. And this leads to this completely inescapable paradox. I mean, to have any kind of sustainable presence, you'd need to make replacement parts right there, on site. But the factory you'd build to make those parts would itself be dissolving faster than it could make anything. It's a total chicken and egg problem, and there's just no way out of it. But you know what? Let's just pretend for a second. Let's say we could magically solve all those engineering problems. We still have to get people there. And it turns out the journey itself inflicts such a devastating biological cost on the astronauts that the mission is pretty much a non-starter from the get-go. So even a short mission, we're talking just 30 days at Venus, requires a 9-month round trip. That's 4 long months to get there, 1 month of operations, and then another 4 months to get back. That's the better part of a year spent in the incredibly harsh environment of deep space. And here's what that 9-month journey does to an astronaut's career. The radiation they'd soak up on a single trip could easily use up 75%, maybe more, of their entire career limit. A mission to Venus would very likely be the last mission they would ever fly. It's a professional one-way ticket. And during those 9 months floating in a tin can, their bodies would literally break down. They'd lose bone density at over 1% a month. Their hearts would weaken. They'd risk permanent damage to their vision. And that 1 month in 90% gravity, it's nowhere near enough time to reverse 8 months of decay. You'd arrive at Venus already weakened and compromised. Okay, so if we can't build a habitat in the atmosphere, and we can't even survive the journey, what about the ultimate sci-fi solution? Terraforming. Just change the entire planet to suit us. It's the grandest vision of all, but the scale is, well, it's almost impossible for us to even comprehend. So what would it take? Just to cool down the atmosphere, you'd need this much energy. That's a 1 with 27 zeros after it. I mean, I can't even wrap my head around a number that big, but let's try to put it in perspective. That is the entire energy output of all of humanity for the last 300 million years. This isn't just some engineering challenge we haven't figured out yet. This is a problem of sheer, mind-boggling physical scale. But let's say, even if we had all that energy, we just don't have the time. A project like this would take centuries, maybe even millennia, to complete. And here's the hard truth. No government, no culture, no human institution has ever survived that long. The project itself would outlast its creators by generations upon generations. And that really brings us to the real takeaway here. Venus isn't some failure of our imagination or engineering. It's a profound lesson in our own limits. It teaches us the critical, crucial difference between a technological challenge we can eventually solve and a fundamental law of physics and chemistry that we just can't. So maybe we've been asking the wrong question this whole time. What if Venus, our brilliant, beautiful, and utterly lethal sister planet, isn't a world for us to go out and conquer? What if it's a mirror, showing us the hard boundaries of our own existence in the cosmos? A lesson, maybe, that some places are just not meant for us.